Just a little practice with the phases of matter and how they work together. We talk about gases, liquids, and solids during class. Here's an example of a graph of equilibrium vapor pressure. As soon as we hear equilibrium vapor pressure, we should think of two phases. Vapor pressure is of the liquid. Liquid wants to boil or become a vapor. And obviously then you have gas as the other phase that's involved. You notice here that we have vapor pressure, which would be the liquid, on this side, and it is in torr. You've got to have units. Down here we have the temperature of the system. So we can see the horizontal and the vertical axis, independent and dependent variables here. Looking at the graph, which one of these substances has the highest vapor pressure and which one has the lowest? What we need to do is consider what phase they're in. Here you notice we like to use 760 torr as our standard, which is also equal to 1 atmosphere, which is 101 kilopascal, or 760 millimeters of mercury. So right here is the standard boiling point of any substance. And you'll notice that substance number 1 is already above that line. It means it's already boiled. Whereas these substances, if you go across below here, they haven't boiled yet. This one hasn't boiled yet. You go all the way across, and this one actually hasn't boiled at all until that temperature. So number 1 would have the highest vapor pressure, the most tendency to boil, and number 4 would have the least. And you can see why. Look at the temperatures down here. You need a very high temperature to get it to boil at whatever pressure you're using. Whereas this one, as soon as you reach 5 degrees even, it's already boiled off. Room temperature is 25 degrees. Substance 1 is already boiled off in room temperature. Again, we can turn it around and say which one of these is water. But vapor pressure is an intensive property, meaning that we can use it to identify it. To do that, we go with the 760 standard pressure or normal boiling point, and we know that water is 100. Take a look here. There it is right there. Number 4 is water. What temperature would number 2 normally boil at? Number 2 is this line here. Normal means 760. We go over to the line, and it's right about there, and we come down just under 30 degrees. This is probably ether. And you could say the same thing, what temperature does 3 normally boil at? And you go 760 again, all the way over to 3, and you come down to about 80 degrees. That's probably alcohol. What is required to get number 3 to boil at 70 degrees? So here's 70 degrees, you go up to number 3, you go across. We'd have to lower the atmospheric pressure to about 570 torr. And how could we get number 2 to boil at 550 torr? At 550 torr, we go to number 2. It could actually boil at 25 degrees. This is 20, that's 30, that's 25 degrees. So this just shows you how to work with vapor pressure and temperature to figure stuff out. Then let's take a look at this graph. This is a graph of all 3 phases. You have solid, liquid, gas, and there's our triple point, where theoretically all 3 phases can exist at once. Look at these lines here. And now if this is solid and this is gas, that line has to represent the difference between solid and gas. It's a phase change. Solid to gas is sublimation. Gas to solid, this whole line represents deposition. This line, solid to liquid, what happens there? The phase change of melting or freezing. So anywhere on this line is melting or freezing, depending on the pressure and the temperature. And then this line represents liquid to gas. Anywhere on this line is the boiling point if you're going this way, condensation point if you're going that way. What would be the normal boiling point and the normal freezing of this solution? As soon as we say normal, we're talking about standard pressure. Standard pressure in atmospheres is 1 atmosphere. So we go to this line, and if we want boiling point, we need the line that's liquid to gas. So we keep going over. Right here's the line between liquid and gas. This is the boiling point. We go down, and it's about 800 Kelvin is the temperature of the normal boiling point of this substance. Come over just to this line, from solid to liquid. That represents melting point, solid melting to a liquid, or you could do the freezing point in the other direction, liquid to solid. But right there, you come down, it looks like it's about 320 torr. Okay, and then I said, what about 300 degrees, 0.2 atmospheres? Let's do it that way. Here's 0.2 atmosphere, and there's 300 degrees. What phase would that be? It's the gas phase. And we can do that with any of these. What if we had 500 K, that's here, and 1.4 atmospheres? 500 K, 1.4, we go up, and you can see clearly that's a liquid. So this is how to work with these graphs.